Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 140 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. My name's Tim Robertson, the host of the Observer's Notebook, and also the coordinator of the training program within the ALPO. Thanks for downloading and listening. The ALPO collects and analyzes observations of various solar system bodies and associated phenomenon, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers, also known as the Strolling Astronomer. This podcast depends upon donations from you, our listeners, to keep it alive. If you enjoy what you hear on the podcast, you can donate to it via Patreon. Even more generous, for $5 you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can help us out by going to www.patreon, that's patreon.com/Observer's Notebook. If you'd like to join the ALPO, membership begins at only $18 a year. Find out more at www.alpo-astronomy.org. And we're also on Facebook. Just search for ALPO Astronomy. And the podcast also has a Facebook page as well. Just search for Observer's Notebook. If you enjoy what you hear in the podcast, please subscribe. That way you'll never miss another episode. And now, episode 140 with Bob Lunsford. And you know what that means? Meteors. Enjoy. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. Again, we have on the podcast, we're talking meteor showers, so that would just mean one person, Bob Lunsford. Welcome to the podcast, Bob.
Thank you very much. It's been a long 3 months. Our yearly drought during the winter season, where the northern hemisphere is devoid of much meteor activity.
That's true. That's true.
So between the Quadrantids in early January and the Lyrids in mid-April, there's not a whole lot going on this side of the world. I should say down the southern hemisphere, though, they have a few little outbursts here and there, but none of them compare to what we get to see up here. So,
okay.
So if you want to watch meteors, be north of the equator, and you want to see bright stars and good Milky Way overhead, go south of the equator.
Well, we're not here to talk about faint fuzzies. We're here to talk about shooting stars and meteors and bolids and nova and not nova.
You betcha.
All right.
Well, our first opportunity is the April Lyrids, which will peak on the night of April 21st, 22nd. This is one of the lesser strong annual showers. It has produced outbursts in the past, but they are few and far between, averaging about 60 years. The last one was in 1983, I believe. And there's another one predicted in, I believe, 43, if I'm not mistaken, right around that year. So. Okay. What we can expect this year is just a handful of meteors from Lyra per hour, mainly due to the moon's phase, which will be 1 day before last quarter. Oh. So we're talking about 60% illuminated, rises between 1 and 2 in the morning at that time. So as the radiant, which is actually located in eastern Hercules and not Lyra, but since Vega is only 10 degrees away, I guess that was a better name for it.
Okay.
Like I said, while the radiant is getting highest in the sky, the moon will be doing its thing by obscuring all the fainter meteors. So you have two choices this year. You can watch while the radiant's fairly low prior to 1 a.m., without moonlight,
Okay.
or you can wait till the moon is higher in the sky, and while the radiant is almost overhead. To be honest, the rates are probably going to be about the same either way.
Okay. And what is that?
Well, if you see 5 an hour, you'll be doing good.
Okay.
When the radiant's only halfway up, you're only seeing a small fraction of the available meteor activity.
Right.
So, early is nice. The radiant's low, no moon. Look toward the east. You can get to bed on time. It's was the April 21st, 22nd, so Thursday night, Friday morning. Of course, it's a work day.
Mm-hmm.
Or if you're a diehard, you can face away from the moon and then look high in the northern sky and see what you can see then, which I bet won't be much more than 5 an hour.
Okay.
The Lyrids do produce an occasional fireball. I've seen a few myself, but with such low rates, it's difficult to call a fireball shower.
Okay.
So last year we had the moon set about 3:00 in the morning.
Mm-hmm.
It was a waxing gibbous, so we had 2 hours of dark skies last year, and I was out in the middle of the desert near the shores of the Salton Sea watching them.
Oh, okay.
And it was good. Maybe 5 to 10 an hour at best, but nothing compared to the Perseids and the Geminids. Yeah. So, but it's enough to whet your appetite after what we've endured for the last three months.
Yeah. Now this meteor shower is also associated with a comet, right? Comet
Thatcher, which was discovered in 1861.
Okay.
And in the year 1922, which is 61 years later, there was an outburst of the Lyrids when they reached 60 an hour.
Oh, wow.
So, and another 61 years added to 1922's 1983.
Mm-hmm.
And we had an outburst, and it was rough, again, about 1 per minute, 60 an hour. And unfortunately, it only lasted a few hours, and it peaked over the eastern United States. And I remember driving out toward my dark sky site at about 11 o'clock, and I was seeing quite a few meteors shooting, across the freeway there. Wow, what's going on here?
While you're driving, huh?
While I'm driving, I
wow.
mean, I'm driving east. I can see these meteors. So I get to my site. I jump in my nice warm sleeping bag, and I don't see hardly a thing. And I find out that just the 3 hours previously over the Atlantic and the eastern seaboard, they reached 60 to 80 an hour. So just missed that one.
So what caused that outburst? You said it repeated 60 some odd years later.
You know what? They believe that it's their influence from Jupiter. When Jupiter approaches a comet, he creates a clump. Mm-hmm. And I guess it must be directly opposite the comet. And
this is a very long period comet.
Right. We're talking, I believe it's 450 years.
Yeah. Yeah. So that's what surprises me, that it would have an outburst in such a short period. Because usually I would imagine most outbursts come when the comet's closer to the Earth and Sun.
Right. We have also outbursts of the Ursids when the comet's at apogee, or I should say aphelion. So there's still some mysteries of why this happens, but we believe that Jupiter has something to do it, where it pushes the particles inward, closer to the Earth's orbit. We know this for a fact for the Perseids, and we're expecting a really, really strong Perseid shower in 2028.
Oh, wow.
Due to this fact. So I don't know if I'll be around in in 2040, but if I behave myself, maybe I can catch the second outburst there.
If I'm still doing a podcast by then we'll get together again and chat about it.
I'll mark it on my calendar.
Oh, yeah, do that.
Okay. While you're observing the Lyrids, and if you happen to be looking east, you may notice some meteors shooting up from the eastern horizon. And chances are those are members of the Eta Aquariid shower, which begin right about the same time the Lyrids do, but they don't peak until the first week of May. Now, these Eta Aquariids just happen to be members of particles released from Halley's Comet.
Oh.
And the Eta Aquariids are the outbound particles of Halley's Comet. Now, we also encounter the inbound particles of Halley's Comet in October, known as the Orionids. And they circle around the sun, and when we meet them again, it's early May. So, and the two streams are very similar. They instead of a sharp maximum like the Lyrids have, they have a long, drawn-out plateau-like maximum, which will be centered on May 6th this year. So, for about a week centered on May 6th, the rates for the Eta Aquariids will be pretty much the same, which is about 5 to 10 per hour, as seen from our latitudes. And these meteors will be intersecting the Earth at almost a head-on direction, which means they're very fast, and almost all the brighter ones will present persistent trains, which are like smoky trails after the meteors have disappeared. Now, unlike the Lyrids, the moon is perfectly situated for the Eta Aquariids this year.
Oh, great.
We have a last quarter moon 2 days after the Lyrids, which will be on April 24th. So you can actually start watching then, because the moonlight at last quarter is much less than it is at full. But the circumstances improve with each passing morning. And I would say by May 3rd, rates will, if you're observing from a dark sky site, rates may be able to reach 10 an hour. Now, there's a small problem with the Eta Aquariids. The radiant's only located 45 degrees from the sun. Oh. Yeah, so
it's right before sunrise too. You got to be
that is correct. It's due west of the sun that time of year by about 45 degrees or 3 hours in right ascension. So these meteors are not visible prior to roughly 2 a.m. Onward. So at my location here to San Diego, I start watching about 2:30. At that time, the radiant is lying right on the horizon, and from 2:30 to roughly 5, I get my best views of them. Now, I have seen as many as 30 an hour from the shower from the San Diego area.
Wow. Now, is that from San Diego, or is that from out in your dark sky?
That's out in my dark sky.
Okay. All right.
Yeah. Actually, they're best seen from the southern tropics because the radiant has a chance to rise higher in the sky because it's fall there instead of spring here, so that their night is longer than it is here. Yeah. So the radiant from the southern tropics rises higher, so they get a higher rate of activity. So from down there, probably see 20 an hour at best this year versus 10. And like I said, if it happens to be cloudy right on the date of maximum May 6th, don't hesitate to observe on a clear night after that, because the Eta Aquariids will be good.
Yeah, they hang around a while.
They do hang around a while for sure. Like I said, for a solid week centered on May 6th. And the moon will cooperate. It doesn't reach first quarter until about the 10th.
Perfect.
So, and by that time, the rates will start lowering. And you'll probably be too tired to watch anyway. Now, next year is going to be an exciting year for the 8 Aquariids because we're expecting outbursts in both 2023 and 2024. And what we mean is every 12 years ago, again, we expect Jupiter to interact with the particles that passes near. So we'll have a bunch of particles that are going to be pushed closer to the Earth in both 2023 and 24, which means the peak rates could be more like Perseus, 60, 70 an hour.
Goodness.
Yeah. So that certainly sounds exciting. So what that means for me, I'll probably get back up to 30 an hour, but those down in the southern hemisphere maybe much better. Now, this happened to the Orionids back in 2007 and 2008, and we didn't know what was going to happen then. But I remember I was out near Fort Irwin in the middle of the desert that particular October, expecting to see the normal 20 Orionids an hour. And by golly, I was getting 70 and 80. Wow. And it was very, very impressive.
Yeah. So when you see a meteor shower like that, it takes you back. It really does. It just.
No doubt.
Very cool.
So we have two possibilities there. And also in May, we have the possibility that the Earth may encounter some debris from a minor planet and 2 comets.
Oh.
And let's start with the first one, which occurs on the night of May 15th. Now, the object we're talking about is minor planet 2006 GY2. Now, this happens to be a binary minor planet, which means it has a little moon orbiting. They had a real close encounter with the Earth back in 2006 when it passed only 6 lunar diameters away from it. I'm not certain of the exact circumstances, but they seem to think that the debris field is going to be quite thick for this particular swarm, I should say. And the timing, believe it or not, is good for North America. Yeah. It's going to be 10 hours, 20 minutes on the morning of May 15. And to figure that out for Pacific Daylight Time, that sounds like 3:20.
Okay.
Now, the radiant will be in Hercules, 3 degrees east of the fairly dim star known as Tau Herculis. Now, we're going to be talking about the Tau Herculis later on in this podcast because that's the name of the third outburst I'm considering. This is just a coincidence.
Okay. Different object.
Different object completely.
Okay.
The one bit of bad news I have about this is that on May 16th, we will experience a total eclipse of the moon, which means on the 15th, the moon will be 99% illuminated. Can you believe it? If this was to happen exactly 24 hours later, it would happen during the eclipse of the moon.
Yeah. Wow.
So close. So close.
And those types of events too, a lot of times we'll witness, meteors possibly impacting the moon during eclipses too.
Definitely.
And for it to happen during a shower like this, that would be amazing.
That would be amazing, but we miss it by 24 hours. So
next time, plan it better, will you?
Yeah, I'll have to do that. But I can't guarantee that anything's going to happen, especially with the full moon. But if it happens to be clear at 3:20 Pacific Daylight Time, now I imagine by the time that you reach, let's say, the Mississippi River eastward, we're going to be talking about morning twilight. So probably east of the Mississippi River, you're going to not be able to see this due to morning twilight.
Okay.
But those in the mountain time zone should have no trouble. Still should be dark at that time. So, like I said, if it's clear May 15th, give it a shot. You never know what you see.
Sounds good.
Now, the next one I even have less faith in because I tried for this display in 2014, and I was driving to the local astronomical site in the mountains, and we got just totally clouded out by the marine layer, which you well know.
Mm-hmm.
And being at 4,000 feet, I was kind of shocked. I didn't think it could reach that far. Believe me, it did. So I ended up going all the way down to the desert. And it was just as windy as can be down there.
Yeah.
But I did find clear skies. I sat in my truck for 2 hours in the back of the truck and saw one meteor from this display. So the circumstances for this particular encounter, which happens to be with Comet 209P Linear. I don't know if you remember that. Mm-hmm. Everybody called it the Camelopardalis of May of 2014. Well, that got a lot of press, and I didn't see a whole lot. Okay. So I was not impressed. But this year we have slightly worse circumstances around 8 Universal Time on May 15. So that would be 1 o'clock in the morning on the 15th of May. And looking at my trusty calendar, that will be a Wednesday morning.
Okay.
So the one meteor I did see was pretty spectacular because it was really slow, orange colored. You could see it fragment. And lasted about 3 seconds.
Oh my goodness!
Well, so
that was worth it.
Well, that was early in the session too, so it got me kind of excited.
Yeah.
So,
but these aren't these last two are not meteor showers, though, right? They're just outbursts from something else.
They're possible outbursts from the encounter with debris from these objects.
Okay.
The problem is we can time it. We know where the radiant is, but we don't know the density of these particles in space.
Yeah. So
if they're scattered, we're not going to see anything. If the particles are dense, we could see some activity.
Okay. And they don't happen every year like most meteor showers.
Most definitely. Yes. Most definitely. So that leads us to our last entry for this session. And the most interesting. Now, back in 1930, there was a comet discovered by Swassman and Walkman. I didn't catch their first names, but the comet is known as Swassman and Walkman 3.
Okay.
It was predicted to pass close enough to the Earth to produce a meteor shower. So in early June of that year, there were several organizations that tried to observe, and nobody saw anything except for one observer in Japan. And he happened to claim that he saw over 100 meteors in 1 hour with the full moon and light cirrus clouds.
My goodness.
So everybody's scratching their head about this guy because to see faint meteors, I don't know if I mentioned it, but he claimed most of the meteors were 5th magnitude.
Well, okay. But
yeah, that's icing on the cake.
Yeah, so with the clouds?
With the cirrus clouds and the full moon.
No, okay.
So everybody's taking that observation session with a grain of salt.
Okay.
Which basically means no one has ever seen much from the shower at all.
Okay.
But in 1995, the Hubble Space Telescope captured this comet breaking into several pieces and created a large debris field. And they got the I don't know if you call it, but there was spectacular pictures of all these little mini comets following the main one, and just all this dust all over. So that was very interesting. I managed to capture a few video members of the shower in, I believe it was around 2006. Nothing spectacular, just a couple at night, but it was cool just to know that they came from this display. Now, there have been research on the 1995 debris breakup of this comet, and some researchers think that yes, we're going to pass close enough to see some meteor activity from this, and some say no. Now, the reason it could go either way is we don't know exactly how that dust spread out from the comet. Now, most of it logically would seem to fall behind the comet and form the comet trails. Right. So, in order for this to occur, we need a great amount of debris to actually pass forward of the comet, so to reach the Earth before the main nucleus. So that's one bugaboo against this happening. You have to have the particles in front. The second problem is most debris from comets are measured in micrograms, and in order for this shower to be seen, we need particles to be at least a gram or larger. And the reason I say this is because this comet is basically encountering the Earth from behind. So any meteors that we see are going to be slow. So if you take a 1 gram particle from this comet, it's predicted to produce a meteor of second magnitude. So if that same size particle were coming from the Geminid, which is a meteor velocity shower, this particular 1 gram particle would produce a meteor of -1 magnitude.
Wow.
Take the same particle from a Leonid shower at 72 kilometers a second, that same meteor would be -4. So we're talking a difference of 6 magnitudes.
Wow.
Just due to the velocity.
Huh.
So
that's crazy.
That's a lot to ask for, isn't it?
That is a lot to ask for. I see why you're excited about that too, because there's potential there.
Well, yeah, you know what? It could be one heck of a meteor shower that's too faint to be visible to our eyes. Yeah. Radar might go crazy, but those meteors are all magnitude 7 and fainter.
Yeah.
So I'm not overly excited about this. I'm certainly going to be outside because I'm Southern California, Arizona, Nevada are the prime spots to see this particular display, because it expected to occur at 10 o'clock in the evening on May 30th.
Okay.
So,
where in the sky?
Where in the sky? Well, these meteors were originally called the Tau Hercules. I noticed people are getting away from that because the most recent studies indicate that the actual radiant is going to be in Boötes, about 5 degrees northwest of Arcturus.
Okay.
So we're talking about quite a ways from Hercules, further west. So I notice people are calling these the 73 Ps, which is short for 73 P Swassmann Walkman, or calling them the Swassmann Walkman 3s. So I kind of like that because I know the Draconids of October used to be called Jacobini Zinnerts.
That's right.
I said, that kind of sounds good off the tongue,
It does, yeah. I always like saying Jacobini Zinner.
Yeah. So, but like I said, whatever you call them, Tau Hercules, 73 Ps, or Swassmann Walkman 3s, They're not going to be coming from Hercules. They're going to be coming from Boötes.
Okay.
So
10 o'clock at night. So that makes it, that's Pacific time too.
that is Pacific time, right?
Got it.
So let's see what day that's going to be, a Monday evening into Tuesday. So no weekend observations this time around, but this one might be worth it. If it's clear, definitely step out. If you're really serious, go to the darkest observing site you possibly can, because you may see a bunch of 5th and 6th magnitude meteors.
Okay.
They'll be very, very slow, just above satellite speed. So,
really?
I'm talking about slow. These things will probably be visible for maybe 2 or 3 seconds, but only travel 5 degrees maybe.
Okay.
Now that's for your average meteoroid. Of course, if you get a brighter one, it may travel longer and be more visible. But you know what? I'm going to go to my dark sky site, and if I see one good one, I'll be happy.
There you go.
But you can bet the press is going to get a hold of this, and they're gonna make another Kohoutek out of it.
No, please. Well, maybe it'll bring people to observe it though, and then you'll get some reports for it. So.
Well, there's nothing wrong with that.
There's nothing wrong with that.
There's nothing wrong with that. Even if you're out there for an hour or two and you see nothing, that's fine. You made it, zeros count as a session, and helps us understand what happened. So what else can I say?
Yeah, that's the key. What type of observations you want submitted, even if you go out and observe during that time period and you see nothing, record your seeing conditions, record the limited magnitude you can see from your observing site, and send a report. I mean, that's a report. That's
most
science.
Definitely.
That's something we want to know. If you saw nothing and you had 5th magnitude skies, it's important to know. So please get out there and observe these meteor showers, even if the moon's going to interfere a little bit. But this sounds like a good opportunity to really, investigate these other 3 opportunities.
Most definitely. And to have 3 of these occur in 1 month is pretty unusual.
Mm-hmm.
Now, I know folks that are going to be coming from other parts of the world to dark remote sites in our desert. And I sure wish them well, and I hope their trip isn't in vain.
Mm.
But I went to Spain for the 99 Leonids, but that was pretty much a sure bet.
Really?
Yeah.
You went all the way to Spain for a meteor shower? Wow.
Yeah. And that
you are dedicated, sir.
Well, it was worth it. That was a very, very good display.
Well, Spain is also nice too.
In November, it was a little chilly, but we were prepared, and we all sat on a mountainside and saw a very good display. This is a little different. We have no idea how strong this is going to be. We know the time it's going to happen, which is right around 10 p.m. But
you said that's on the 30th, right?
That's on the right.
Yeah.
It's 5 universal time on the 31st, which is actually the 30th for us here in the United States.
Okay. Well, I'll stay up late. I'll stay up that late and head out to a darker site, maybe where our observatory is locally, and go see what I can see.
That might be worth it. Yeah. Now, there is an article already in the latest ALPO journal.
Okay.
So you can read more on this this particular possible display. And after this, June is pretty much a dry month, and so is the first part of July. And second part of July, we finally enter the real meteor season in the northern hemisphere.
Okay.
So we will save that for another podcast.
That sounds like a plan. All right, Bob. Well, I'll put your contact information in the show notes, along with the additional information and the links to these various sites too.
And I'll be providing more details as we approach the date in my weekly Meteor activity outlooks. So be sure and look at those.
Okay. And where are those available?
Those are available on the ALPO website under the Meteor section.
Okay. And I'll put a link for that. So everybody.
Those are updated
right
every Friday.
Oh.
So we'll soon be discussing. I will also be writing a detailed article on the Ada Aquariids. So you can also look forward to that.
Okay.
So I hope people will have good weather and good viewing, and that their efforts are not in vain.
That would be nice. It would be nice to see a really nice meteor shower.
It's been a long time, hasn't it?
It has. Well, Bob, I want to thank you for coming on the podcast.
My pleasure, and I look forward to doing it again.
All right. Talk to you later.
Okay. Bye.
Well, that'll do it for this episode of the Observer's Notebook podcast. Again, I want to thank our meteor shower expert, Bob Lunsford, for coming on the podcast today. We upload new episodes of the Observer's Notebook on the 1st to 15th of every month. You subscribe to us on iTunes. If you do, please leave us a rating. I really appreciate it. You can also listen to us on Apple Radio, iHeartRadio, Soundcloud, Spreaker, Google Play, Stitcher, Amazon, Echo, Spotify, and this podcast is now available on the ALPO YouTube channel. Head over there and subscribe to that as well. You can help support the podcast by donating to it via Patreon. You can give up to $35 a month, where you receive 1 year's membership to the ALPO and producer credits on the podcast. And with that, I want to thank the producers of this podcast, Steve Siedentop and Michael Moyer, for their generous support of the Observer's Notebook. The link for Patreon, as well as the link for the ALPO, is in the show notes. If you'd like to contact me, my email address is commentman@commentman.net, or you can get a hold of me on Twitter at ObserversNBPod. Until next time, my hope is you always have clear and steady skies. Thanks for listening.
Hello, Tim.
Hello, Bob.
How are we doing today?
Good, man. How are you?
Good. Hey, it was great to see Elizabeth on Saturday, wasn't it?
Yeah, it was. Good to chat with her.
Yeah. Got good memories, her and John, back in the early days there.
Yeah. Yep. That was fun.
Yeah.
Nice little chat. Nice to see you pop on, too. That was good.
Hey, we got the Lyrids, and I'd like to discuss the other events of May coming up. We have the Ada Aquariids 2 weeks later.
Okay.
And we have 3 possibilities of the Earth intersecting debris from a minor planet and 2 comets.
Oh, sounds like fun.
So this should be a halfway decent podcast.
Hey, anytime you're on, they're good.
Well, that's good to hear. So.
You're a very good guest.
I try, man.
Yeah. All right.
So anytime you're ready to fire it up.
All right. Give me a minute.